Nandito na nga, nandito na nga, nandito na nga Ang Mayon Volcano'y parang smoke machine Buhawi sa Ortigas Building Si Rizal Nilamon ng Manila Bay Nahati ng Marcos Highway Baby, don't stop, keep moving around Even if the whole world's crashing down Kahit na may asteroid na papagsak At sa landslide ay mapahamak Nandito na nga, nandito na nga, nandito na nga Ang end of the world Nalihis ang riles ng tren sa Japan Di na siya kaka
Now on our week 4 topic entitled Using Aggregate Functions, Table Joins, and Subqueries. So for this lesson, we are going to use the following tables for most of our examples, and then later on we have sample exercises. So kindly copy the table for SQL Server and MySQL, and also insert all the data that are available for the said tables. You could try to make a sample data of your own, or you could try copying the data from our examples while I am running the sample codes. Okay, so first up, our aggregate functions. So our aggregate functions consist of count, mean, max, sum, and average, or ABG. So these functions return a particular value, okay, like count. This used to tally the number of non-null values of a column or attribute. Maximum and minimum helps you find answers to problems such as the highest and lowest value in a particular table. The sum sums or adds up all the values for a given column, and the average returns the arithmetic mean or average for a specific column. Okay, notice that all of these aggregate functions, the code works both for SQL Server and MySQL, so we do not have to change anything. So let us try to first use count. So select count distinct B code from table product. I'm going to use MS SQL. Try to run the code. So this will count all the B code that is found and is distinct inside the table product. Next, mean max. So in this instance, we use the where clause in max to find a price which is equivalent to the maximum price. Okay. So notice we have encountered an error. The reason for that is if you want to use aggregate functions inside your where clause, okay, it is not possible. What you should use is a having clause. So we will discuss that later. So what we could do is basically just either avoid using where in when we are using aggregate functions, or resort to using having, which we will discuss later. For example, we are going to execute this code, max min. Okay, there is no return data. Let us check. product, P price, okay, what minimum, mean, okay. We'll also try for summation, okay. We'll also try summation using our computed values here and plus our average. Let us try the sum of our two computed columns. Okay. Now, what should we do if we want to group our data based on another column? In order for us to group our data in or when using aggregate functions, we use the group by clause. As you can see here, we could use our V code, group our data by V code, and then for each V code, we will display the distinct V code, okay, or product code. Okay. Notice these are our three V codes. So for V code 1, we have 2, 101, we have 1, and 104, we also have 1. Now, as I have said earlier, when using aggregate function, we cannot use the where clause inside the aggregate function if we want to limit our result. What we could do is to use the having clause in order for us to filter out the data that we need. So let's say, for example, in this example, we are getting all the sum of the quantity on hand multiplied by the price, which is greater than 500. So all the sum of this particular column result that is greater than 500 will be returned. And then after we will group it according to the B code. So let us try to check. Okay. Okay. So total cost is this one, and this one for the three B code. So let us check the quantity on hand times price for table product. Quantity on hand times price. So let us try to change one of our column. So we will change rod ID 4, have a quantity 1, and then let us execute our having clause and see if it will be returned. So notice because the quantity times P price, sum of quantity times P price is less than 500. It was not. included. Okay. So in this instance, all the group may be code, meaning all the B code having a distinct value will get all their particular sum of QOH or quantity in hand times price. If the total of all the columns or of all the computed columns is greater than 500, we will return it. Otherwise, we will not return it. Okay. What if we try to add another row? So let's say, for example, we code 104. Let us try to add a value under 104. Or we code between and so let's say 5. So 10 times 5 is 500 plus 58. So 558. So when we try to execute this code, because the total according to or group by the B code will be 558. 104 should now be returned. Okay. Okay. So that's it with regards to aggregate function, group by, and having by clause. So next topic is about views or view. Basically, a view is a virtual table based on a select query. The query can contain columns, complete columns, aliases, aggregate functions from one or more table. The tables. The table in which a view is based are called base table. So a view uses the syntax create view, view name, as followed by the select statement. Now, it has the same syntax for SQL Server and MySQL. Okay. So in this example, we will make a view called prod stats. In my case, when I create view, I also use prefix VW. If we are creating table, I have used TBL. Notice TBL underscore. When creating view, usually I use VW underscore. Okay, so it's up to you if you also want to use that particular convention. Try to create our view. Let me set the convention that I'm using for naming views. What I can do is make this style. Try to run the code. Okay. So now the question is, how do we call the view? Now, in order for us to call a view, as I have said based on the definition, a view is a virtual table. You could use select and all the other um, parts of a select statement like where clause, stop, limit. You could also use aggregate functions as long as what you do on a normal select statement you could do on a view. So let us try if this will return something because unfortunately I think it's not supported. Views are not supported here. Okay. So let me try to use a different program. So in this example, I will be using SQL Server Management Studio because our online compiler, if I'm not mistaken, does not support views. So I have the tables here. So under SQL Server Management Studio or other database management software, usually the views are separated. Okay. Take note, views are only virtual table, meaning it is for display purposes only. Management of records such as insert, adding, deleting, updating, you should not use views. Okay, views are mostly used for security purposes. Okay, always remember that. So in this example, let's try to make a view. So create view, view test, then add keyword as, and then followed by the select statement. So let's say, for example, about table office. So select from table office. Okay, okay name office, and then okay ID. Okay, so let's try this one. So view test, refresh, and then view test. If you select, you can see the contents. You can call it like an ordinary table. Select asterisk from view test. Okay, there you have it. That is how you would use a view. Take note, views are not intended for database operations such as adding, editing, or updating, deleting. It is only used for select purposes. And then specifically, we use views in order for us to separate access per particular user, especially for security purposes. For example, we only want particular user to view a particular part or data of a particular database, not all tables. We could set an access right for the view, and then all the other operations cannot be performed by that particular user. That's why views are important in database management system. Okay, so with that finish, we'll go back to our lecture. Okay, the next is joining tables. Okay, when we are joining tables, always remember that in order for us to join table, usually we use primary key and foreign key from one table or one or more tables. Okay. The join condition is composed of an equality comparison between a foreign key and the primary key of related tables. For example, we want to join table vendor and table product because V code is the foreign key in the table product and the primary key in table vendor. The link is established on V code. Here. On our earlier example, I haven't set V code as the primary key for table vendor, but you could do that or you can try that if you want to. Now, when performing joins, the SQL Server and MySQL has the same syntax. So one of the first form in doing joins is we could use a where clause. What you could do is to compare one table column to another table column, usually the primary key and the foreign key. Then you perform the select statement or perform order by clause. You could either do you could also do aggregate functions, group by and having if you want to. Okay, so let us try code. Okay, okay. So notice from two tables, we were able to return a data linking those two tables. Okay, so same goes for MySQL. Okay, now notice in our example, the name of the table is repeated, causing the syntax to be long. Now, in order for us to shorten our code, we could use alias to represent one table to another. In this instance, we represent it by a single letter, but you could use two letters if you want, two, three letters, okay? But of course, because it's an alias, we prefer it to be shorter than the original name. So the shorter code will be this one, but the output, of course, will be the same. Okay. Okay. Now recursive join. Recursive join is usually used when we are connecting a table to itself. Okay. For example, in the table emp table, we generate a list of all employees with their manager's name by joining the emp table to itself. Okay. In that case, you would also use aliases to differentiate the table from itself. Okay. For example, we use the both table M, but one is E, the other is M. Okay. And then we use M MGR is equal to employee number. Okay. I will first check. We need to update this one. Date and date M set M num equals to 3 where 52. Just update that we can use the code in our example. Okay. Okay. Okay, so we made some adjustment to our emp table. So the manager, we have set manager number two. The emp manager, the emp manager value is coming from the emp number value. So the manager of Kolyang and Kung Lao is number two, which is Liu Kang, and manager of Liu Kang is Kung Lao. Okay. So upon executing our code, so notice what we did here is, okay, set the number of our manager, the name of the manager, as well as the number of the employee and the name of the employee. Okay, so here is the output. This is manager number, employee number, manager name, employee name. So that is how you would use a recursive join. Usually when a table is related to itself, we use recursive join. Okay, next, our outer join. So always remember that the outer join can also be called as, or an outer join can also be considered as a left and right join. So a left outer join is a left join wherein all the data from the left side or left table should be visible regardless if there's a match on the right side or right table. Whereas on the right join or right outer join, all the table on the right side will be displayed, all the data on the right side will be displayed regardless if there's a match on the key used from the left table. So this is one form of join wherein instead of using where clause, what we do is use the syntax from table name, left or right join, second table, and then on followed by the first table on the left, and then the column that you need to compare, and then the table on the right followed by the column that you need to compare. So let us try the shorter code by using Alias. We will use Alias, and that will be shorter. Okay. So in this two column, we didn't use an alias because they are unique in the particular table. But if you want to, you could still use that one in order for you not to be confused. Okay. But it will also work without the alias as long as that column is unique to the particular table. Okay. This notice this is a left join. So all the data from table vendor, actually we will place all the column the left, okay, so that it will be easier to see. Okay. All the data from the left table should be displayed regardless if there is no match on the right side. So meaning this particular B code was not found under our table product. Whereas for the right join, Okay. Notice all the data on the right table should be displayed regardless if there's no matching data on the left column, or sorry, left table. Next are union. So union is a perfect tool for combining a common list of data. It excludes or separates duplicate records, meaning it will only return an instance of a particular record. The union statement combines row from two or more queries without including duplicate row. The syntax is select query, union, select query. So in this example, okay, let us first display the value of table cake. Okay, then table fully. Then let us try to run. All the values will be returned except for the duplicate values. In this instance, actually, what I want to do is to rename the ice cream cake into ice cream cake and see if it will still be returned. Okay. Also, be reminded that when using the union column, it concatenates the union clause or union clause concatenates all the column in order for it to return a unique value. So notice here that although the CK price is the same, the CK name was different, so the two values were returned. But if we read equal cake, okay, so notice because we have the same value for CK name on table cake and FD name on table hoodies, single instance will be returned. Union all. So union all is the same as union. However, it includes all the duplicates. So just add the word union all. Okay. Notice duplicates were returned. Okay, next is intersect. Now the intersect command is unique for SQL Server. MySQL has no intersect command. However, okay, we could make an equivalent code for intersect in MySQL. So I will show to you that syntax later. So first, we use intersect for SQL Server. What happens in intersect is that it gets all the same values from the column that you declared to the second table. So when there's a match, it will return the match. Okay. Now for MySQL or MariaDB, what we do is to use a join clause, and then what we do is to compare the columns that we want from the first table to the second table, and then it will return the same instance. You could also use this code for SQL Server if you do not want to use intersect. Okay. So if I'm not mistaken, we need to update. Sorry, I need to update the value of net. Okay. Check. Okay. Sorry. Scram. Okay. Okay. So you have the same output as that of intercept. SQL join operator. The SQL join operator has or returns row with one of the following conditions. So it has the following conditions. For one, have common columns, common values in common columns. It's called natural join. It meets a given join condition, which is equality or inequality. And they have common values in common columns or have no matching values, which are outer join. For the natural join, usually this is the join on condition. Given join condition, join on or where clause, and then the outer join is the left or right join. Okay. Join operations can be classified as inner or outer join. The inner join is the traditional join, in which only rows that meets given criteria are selected. The join criteria can be an equality, natural or equijoin, or inequality, called theta join. An outer join returns not only the matching rows but also the rows with unmatched values for one table or both tables to be joined. The SQL standard also introduces a special type of join called a cross join that returns the same result as the Cartesian products of two sets or table. Okay, so we have a cross join here. So a cross join returns a relational product or a Cartesian product of two tables. So let's say, for example, we will perform a cross join for table cake and table puddies. Let us run it in MariaDB because it will run both on MySQL and MSSQL or SQL Server. Notice what happens here. If you are performing a cross join, the record for each row of one table is multiplied to all the record on the other table. So meaning, for example, in this instance, we have table cake. We have three records. So black chain, ice cream cake, doggy dog. It will be multiplied to each and every record found in the other table that you are cross-joining. So blockchain will have blockchain and ice cream cake, blockchain buko pandan, blockchain vanilla, and then to the second row and to the third row. So 3 times 3 records, it should return 9. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So, okay. Join on. So join on, again, as I have said, it is the same as that of the where clause. So we are still comparing one column from one table to another column of another table. In this instance, we're using the join on clause. Okay. For example, we are to connect the FD ID to the CK ID. Let's check. Okay. So this is the returned result with the same values for FD and CKID. For the outer join, as we have discussed earlier, the left and the right join. Okay. To the left, all the records from table K should be displayed regardless if there's a match on table 2D. Okay. And right join. Okay. Select subquery. So select subquery is a select statement wherein you can use it for insertion of records, updating of records, or deletion of records. So a select query is a query found inside a particular statement. Okay. So when you find a select query inside another statement or query, that is called a select subquery. It can return a single value or a list of values, one column, multiple rows, or it could even return a virtual table. The most common type of subquery uses an inner select statement on the right side of a where comparison clause. For example, select P code, P price of table product where P price is greater than the average price from table product. So let us try to run this example. Okay, so these two P code, P price is greater than the average price from table product. What is the average price? Let us check the average price so that we can check if it's greater than or equal to 25 and 15. The average price is 1,082. So 25 and 15 are indeed greater than 1,082. Okay. Subqueries can also be used in combinations with join. Okay. To mind you, there's another form of using join in MySQL. So notice instead of using on followed by the column, you use using followed by the column that you are trying to connect. But in my case, in my instance, it's preferable to use the join, which is used by both SQL Server and MySQL so that you will not encounter any problem. Okay, so I just showed you this one in order for you to know that there's another form of using join on MySQL. Okay, so this example actually combines one, two, three tables in order for you to come up with the value. So in this example, we are connecting all the customers who ordered a table cake having a cake name of Mocha. Okay. In subquery. So as I have set our examples earlier, the in subquery is like an equal clause. However, the in subquery uses multiple one or more values in our um, work clause. Not just one, but sometimes it can be more than one. So that is how you would use the in subquery. So in this instance, the select subquery could return more than one value, and we are trying to get the CK name of all the values found under our select subquery. Okay, correlated subquery is a subquery that executes once for each row in the outer query. The process is similar to the typical nested loop in a programming language. So a correlated subquery is basically just like a nested for loop. So in a nested for loop, always remember that it will start from the outside and then it will go inside, finish all the loops inside, and then go back to the next number on the outside loop. Okay. So in this example, 1, 1, 1, 3. Sorry, 1, 2, 1, 3. And then go back to 1, 2, 2, 2, 3. Then exit. Okay. To see the correlated subquery in action, suppose that we want to know all the cake prices in which the price value is greater than the average price value for the cake group found in FDID, as opposed to the average for all the cake. In that case, we could do is compute the average price for a cake in the group and then compare the average computed in step 1 to the cake sold in each sale row, and then select only the rows in which the cake price is greater. So in order for us to do this, what you can do is to get the average cake price from table cake, where, okay, notice table cake K, the FDID is equal to the the outer loop table cake C. Okay, notice C represents our outer query, K represents our inner query. Okay, okay, unfortunately, not have the price. Okay, CK PRC, sorry, CK PRC. Okay, there's no FPID for a table cake. Okay, so let's try to fix that first. Okay, I updated our table by adding a column called FDID and setting the following values. So let us try to execute our command. I have said what this does is to get the average price of the table cake, wherein the matching table cake ID from the outer query, okay, gets the price which is greater than the average price. Try to find the cake with the price having a greater average price from that of table cake is the doggy dog cake. Okay. Next, you could also use correlated subquery with the exist special operator. In this example, we have two tables, table customer and table purchase. Now, if you want to return all the customers that have made a purchase, what you could do is to select customer ID from table purchase and find all the customer ID from table purchase that is equal to the customer ID on our table customer. So what it does is return all the customer name that has made the purchase. Okay. We could also use our correlated subquery to find, for example, all the items that has a quantity which is less than the minimum allowable quantity. So in this example, we return the V code and V name of our table vendor where the on-hand amount from table product is less than the minimum allowable amount multiplied by 2. And then you set the vendor code from table product to the vendor code of table vendor. So what I'm gonna do is, because I think not all our columns are complete, so let us try to state our column so that you will see the result. Table product, add column, the minimum. Okay, then quantity on hand, minimum. The table product, then minimum equals to okay. So let us try to execute our code to get all the vendors with product quantities less than the set minimum. Okay, P on hand. So PQH quantity on hand. Okay. So we contact Samsung because our okay, keyboard and printer, which is under V code 0100, 0100 is having a minimum quantity less than our on hand. Okay, so there you have it, our unit for week 4 lectures. Now, what I want you to do, guys, is to perform the sample exercises that I have included. Okay, all the tables are there, as well as the answers. Okay, so kindly perform the exercises. With regards to the table, kindly insert the data that you have found in our table examples. Okay. If you have any queries with regards to the answers, you can contact me. Okay. So the samples here are almost having the same logic as that of your assignment. But if you have any queries with regards to this one, you just PM me in our Discord group. Okay. So thank you guys and take care.